All right, so that one should be pretty straightforward. So one small thing. There was something missing in the util.js that we're gonna need later. If we're going to util.js again and so create test case. We need to add a third argument here, extra. After adding that argument, before this load event, just call the extra with passing it the window object. So this is necessary for the routing tests later. I forgot to include this in the branch. And I should probably, let me just quickly re-upload again. Fix util. Press. Dropbox. Okay, so Dropbox is updated. Okay, so let's go back into the example just now. Let me close all these previous files. And we are at 4.1. Okay, so we have our app, and this one should be very straightforward. So we can just create an inline component counter, and the expectation is it should just render the count inside a div in order to pass the test. And obviously it should take a count prop. That's it. And then this count, the real piece of state, this count, should live in our root component. So you can see that the counter itself simply takes some props and renders it, and the props, the source of truth is in the common parent of all these instances. And so this is the most basic form of state management in a lot of cases, but like in the worst case scenario, you can have all your state in your root component and just keep passing them down to your props, right? But you can quickly see how this pattern breaks down when your component tree structure becomes larger and larger, and it's just completely infeasible to keep passing props over and over again. Becomes extremely hard to maintain. So the next exercise, what we're going to try to do is, the template is almost the same, except that these components do not take props anymore. But we need to maintain the same behavior from our previous exercise. When you click the button, and it calls the increment method of the root component, and all these child components should update together. So we need to find a way to first make all of these child components share the same piece of state. Second, our root component should be able to update that piece of state. And how can we do that? So the hint is that we can use a shared object to serve as our common piece of state. And many of you probably have run into this warning before. Like, if you write a component like this, what warning would you get? Anyone? Yeah, data must be a function, right? So most of you have probably run into that before. The reason that data must be a function is because most of the time we want each component instance to have its own separate, like, unique piece of data. instead of all of these components sharing the same piece of data. But in this particular case, what we want to achieve is to make all of them share the same piece of data. So how can we achieve that? So let's try to do that. So let's give another 5 minutes. Okay, so the catch of this implementation is obviously you can have a shared object as our state, and if we are smart, we can, make it directly return the thing from within the render function. So like, we can do it like this, but you realize that this does not really work. Let's implement the methods first. If we run this, you'll realize that when you click, state doesn't increment. And the reason for this is that Vue never really had a chance to make state reactive. The default, so in Vue, the way to let Vue know that it should make something reactive is by returning it within data. If you return something within data, this is the object that Vue will call the observe or convert function on, right? If we don't do that, then state was never actually passed to Vue, and Vue never had a chance to make it reactive, then nothing will happen, right? So what we can do is just return the same object inside the data function. And now we can do this dot count. So this should do the trick. Let's run it. Nope. I didn't register counter. Okay. So components counter. So now it works as intended, because now Vue's got a chance to take state, convert it into a reactive object, and state.count is proxied onto the counter instance as this.count. Okay, so obviously this counter component is less pleasant than something like this, right? So you might be wondering, why can't we just do this instead? Right? That looks much nicer and easier. Well, in fact, if we change the way we think about this object, we can do that. So the next exercise is about changing this into, so template is still the same, but if we go into 4.3, we'll reuse the previous exercise. And instead, our state is now a Vue instance. And still, all the expectations are the same. Um, 3 minutes. So shared instance. So we've noticed that when a view instance takes some data in, the default behavior is it proxies all the root level properties on that data object onto the view instance itself, right? So we can in fact use the view instance as some sort of reactive data store or a model, which makes it look very similar to MobX in that sense. So if we have, because this is a single instance, we can use directly just do this. Count 0. And more importantly, we can collocate the logic for possible state changes into this instance. So we can use methods for that, right? So if we have this, so now we have something that's pretty neat. We have its state and the way the state could possibly change in one place. And because this state object itself is reactive, we can just directly reference it inside other components without even worrying about, turning it into data first. So now this would actually, this counter component would actually work because when state was processed by view, a view instance is reactive by default. So the idea that it is reactive means when you access state.count, this would trigger a getter, which registers the dependency, which in turn causes this whole render function to be reactive. And later on, when state count changes, this render function will be called again, triggering the counter component to re-render. And in our app here, still needs to register counter, obviously. And we still need to somehow proxy the call to the inc. But now, instead of directly manipulating the state here, we're just calling a function here. So this may seem redundant for this little example, but the good thing is we are hiding the details of how the state actually is mutated. So the details of how state actually is mutated is co-located with the state, with the store itself. This logic may be, in real apps, this logic can be much more complex than just incrementing a count. This can be, this can involve going to an API, fetching some things, doing filtering, comparisons and all that, and eventually mutating the state. And if all these if these state logic is inherently coupled with the state instead of coupled with the logic of those components, then it makes sense to take out of these logic and put them in the centralized place too. So this would become your go-to place. So this state could be. So this pattern actually applies pretty well. So let's say you have an app and you have different kind of data in your app. So you can literally change the naming to a store and assign them names like user store, product store, and each of them is dedicated to dealing with one specific domain in your app. And then they can be directly imported and used in all your components anywhere you want. Even reference them directly inside render functions. So this pattern actually works pretty well for medium-sized apps. And if this kind of domain model-based state management is what you prefer, you can even extend it, build upon it for bigger apps. But this is already getting pretty close to Vuex, which is our, the pattern that's designed to handle bigger scales. And if you've used Vuex before, you will notice that we can rename a few things. For example, we can call this thing the store. And Vuex has this concept called mutations and actions. So the difference between mutations and actions is mutations are the code or the functions that actually changes your state, actually mutates your state. So this is where the mutation happens. And they must be synchronous. The reason that they must be synchronous is because Vuex has a DevTools integration. If you've seen the DevTools integration, you know there's the time travel feature, and we have snapshots of your state whenever a mutation happens. If you want to take snapshots, then it is critical that the mutations be synchronous, because you can compare the before and after immediately after the function is called. If a mutation can contain arbitrary asynchronous operations, then after you call the mutation, you don't really know how long you have to wait until your state has actually changed. So that can make the snapshot comparisons a lot harder to implement. So, and also asynchronicity and the actual mutation of your code is better separated, because asynchronicity is really a sort of a complex topic of its own, right? So essentially in Vuex, the concept of actions and mutations are really just meant to separate asynchronicity from the actual procedures of mutating your code. Also, inside actions, you can do a lot of things like calling to external APIs, whereas your mutations will be focused just on dealing just with the state. Your mutations will take some arguments and mutate the state, and that's pretty much all their responsibility. While in actions, there's a lot more things you can do, and it can involve asynchronicity. So, but we're not going to dig too much into that. We're really interested in the implementation. So inside Vuex, we have something like this. You can do, let's see. Inside our next exercise, and 4.4, we'll see that it's still the same app, except we now have a function called createStore. So this function is essentially trying to emulate a simple version of Vuex. And the way it should work is createStore takes an object, obviously. It takes some state. It takes some mutations. And inside mutations, each mutation function receives the state as the argument. And it operates on that piece of state. So this state will essentially be this object here. Okay? And if you've used Vuex before, you'll notice this is exactly the same as this. Right? So Vuex Store essentially exposes this exact API, except now we want to implement a simple version of it here. Okay? With only mutations, like no concern for modules or actions or anything else. Just do this. And the way you use it is you can reference store.state.count when you want to access state from the store. And the way you trigger changes in the store is by committing a mutation. So commit, then the ID of the mutation. So the ID increment here corresponds to the ID here that we're seeing inside our store declaration. And the internal implementation is for yours to fill up, and obviously, it should follow along from our previous exercise where we're using Vue instances as reactive stores. So, yeah, so essentially what we're asking you to do is use a Vue instance to fit the API requirements that's outlined in the exercise. So let's take 10 minutes to do that.